And welcome to Cranky Calculus. We're going to go through the Squeeze Theorem. Do not forget to like and subscribe to see more videos, and you can leave comments of things that you want to see in future videos so I can help you out here. So Squeeze Theorem, a very simple theorem that has some complex adaptations to it, but pretty much that if we have three functions and f is always the smallest, then g, then h, still going to be the largest inside some type of tight interval here, and the limits on the ends, so f and h are equal to L, then the limit of the middle one will also equal that same value. And you can look at that graph right there and see that that is entirely true. Let's just get to some examples here. So we're going to start with a fairly simple example and get more complex as we go. So for example 1 here, we're going to let the square root of the x to the 6 plus 4 be less than or equal to f of x, be less than or equal to square root of 2x to the 8th plus 4 in the interval from -1 to 1. Find the limit as x approaches 0 of f of x plus 30. Now this is a question where I do not know really anything about f of x other than that compound inequality, but I can use some limit laws here to dial this down a bit. So we're going to get the limit as x approaches 0 of f of x plus the limit as x approaches 0 of 30. And I do not know what that limit as x approaches 0 of f of x because I don't have enough information quite yet, or maybe I do, but I do know that this limit is going to give me a plus whole 30 right down below there. Okay, so let's find out more about f. Well, we are in the Squeeze Theorem notes, so it's a little bit easier to kind of figure out what the heck is going on here. But this compound inequality, anytime you see a compound inequality that has three different functions like this, that usually means, hey, we're about to use the Squeeze Theorem here. So if I look at the limit as x approaches 0 of the square root of x to the 6 plus 4, that's a direct plug-in. I can plug in a 0, and I'm going to get square root of 4, which is 2. If I do that same old thing there on the far side, if I look at this limit and I plug in a 0, I'm also going to get square root of 4, which is 2. So by the Squeeze Theorem, we can say, I don't know why this is writing poorly. There we go. Technical difficulties happen quite often here, and it makes me very happy when that happens. So we can say that the limit as x approaches 0 of f of x is also equal to 2 by the Squeeze Theorem. You do not need to say by the Squeeze Theorem, but I'm just going to just leave it here for y'all to see. So because of that, I can take this value and plug it in there. So I'm going to get 2 plus 30. So my final answer here is going to be a 32. Now, these are more common questions that you'll probably see in college. And maybe they can squeeze some of them in there for AP Calculus. So use the Squeeze Theorem to evaluate this limit as x approaches 0 of x squared times cosine of pi over 2x. So we need to use the Squeeze Theorem here. We don't want to do a direct plug-in. If we were to do a direct plug-in, we would get 0 times a DNE. 0 times DNE does not always produce 0. It does not always produce DNE. Sometimes it comes out to be a number. So just be careful of just directly plugging in 0 when you have a D does not exist. But this does say use the Squeeze Theorem. So we're going to make our own compound inequality. So in order to make our compound inequality, I know the properties of cosine can help us out. Cosine of x is between -1 and 1. That is the limits of the range. That's how all sinusoidal functions work with cosine and sine. Okay. So now, if I were to change the period up, or if I were to shift it horizontally, anything that's going on with the input does not affect what is going on with the range. So I can say that this is the same thing as cosine of pi over 2x. All I'm doing there is changing the frequency and period. That still means that my trig function is between -1 and 1. I'm trying to, if you can tell, make this appear to be what I just underlined right there, that x squared cosine of pi over 2x. The only thing that's missing now is if I can multiply everything by x squared, and then we're going to get this function, or this compound inequality right here. So now I have the Squeeze Theorem set up. So now I can go ahead and state that the limit as x approaches 0 of negative x squared is equal to 0. Limit as x approaches 0 of x squared is equal to 0. Just by direct plug-in, that is sufficient to say now that the limit as x approaches 0 of x squared cosine of pi over 2x is indeed also equal to 0. So quick little video here for you teaching the squeeze theorem. Do not forget to like and subscribe, comment anything else you want to see, and I'll make it happen.